Once again, good morning my dear students and welcome to the electronics class. Last meeting we talked about the principles and theories of a CRT type color TV receiver, familiarizing the different parts of the TV receiver and their functions as well. But by this time class, our activity will be focused on the measurement of the voltages and the frequencies. These are the AC and the DC voltages that are at the different parts of the TV circuits, and the frequencies of the AC signal that are at the inputs and the output lines of the different circuits also here of the TV receiver. With this activity class, we in dire need the following equipment and test instruments. For the equipment, of course, we need a TV receiver, a DVD player, which is the source of the picture and sound signal for the TV receiver, and a variac transformer, or the so-called variable AC transformer, that will provide different levels of AC voltages to the TV receivers. And for the test instruments class, of course, we need this analog multimeter, the digital multimeters, which are needed for the measurement of different voltages of the circuit, and this oscilloscope. Oscilloscope, by the way, is a test instrument. It is a test instrument which will measure graphically the time varying voltage values and the frequencies of the AC signal. No? Going back again to this variac transformer, or to what is really the operation of the variac transformer. Okay. Variac transformer actually has two windings. The primary, we have here, and the secondary winding as the output line. It is equipped with variable, or the so-called rotor shaft, that will vary the setting of the voltages at the output. Now, actually, the primary winding is connected to the outlet that distributes 220 volts to this variac transformer, and the output now is at this outlet. So let us measure the output voltage of this secondary winding. Okay, we will set this to AC volts. Okay, the AC voltmeter now is at AC level, or AC setting. Now, rotating this rotor shaft of a variac transformer will also vary the voltage at the output. Okay? The minimum level actually is almost 0 volt. And the maximum level is at 270 volts or 268 volts. Okay, we will set it to 220 as the required amount of voltage for this TV receiver. And the standard voltage also at the output of the outlet, which is distributed by the Soleco company. No? Okay, you have here. What is seen on the screen actually is the sinusoidal waveform, the signal which is actually distributed by the electric company, specifically the Soleco or the LeEco company. It is a sinusoidal waveform. So, what is that sinusoidal waveform? Okay, we have here. Let us try to figure out or compute. We have here a sinusoidal waveform as it is seen on the screen. We have here the positive alternation, and here is the negative alternation. The 220 volts, which is now at the outlet, no, we measured the voltage at the outlet, and it reads the testers there. The tester registers 220 volts. That 220 volts is the measurable voltage by our tester, and it is actually the effective value. It is only 70.7% of the peak value of the amplitude. So, which is 220 volts. We have also at the negative alternation, negative 220 volts, which is 70.7% of the peak value at the negative alternation. So, it is a root mean square, the effective value or the effective capacity of doing work. But actually, the Soleco or the LIECO is giving peak value, which is 100%. And what do you think is the amount of the voltage of the peak value? Peak value is equal to RMS times 1.414. 1.414 or 220 volts times 1.414 is equal to 311 volts. 311 volts is actually the maximum voltage provided by the Soleco. But what is measurable by our tester is only 70.7%, and that is 220 volts. No? Remember, the peak to peak is around 622 volts. Because peak to peak value, the peak of the positive alternation and the peak of the negative alternation, when they are added, the sum is 622 volts. Diba? 311 plus 311, 622 volts, the peak to peak value being distributed. But what is measurable is only 220, which is only 70.7% of half of the cycle, or one of the amplitudes, positive and negative amplitudes. Okay. For the frequency, by the way, how do you read this one here? On the screen, actually, there are divisions. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 divisions on its vertical axis. That measures the amplitude, the height of the amplitude. When you are measuring the height of the amplitude, you are measuring the voltages. And that is when you read the divisions on its vertical axis. But when you read the divisions on its horizontal axis, there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 divisions. When you read the divisions on its horizontal axis, you are measuring the frequencies. So right now, actually, this waveform is a sinusoidal waveform which is provided by the electric company, the Soleco. No? This is the actual signal which is now distributing by them. Okay, we can actually measure. No? There are, at the front panel, actually, of this oscilloscope, there are lots of controls. There are 2 inputs or 2 channels, channel 1 and channel 2, with the respective controls. No? Actually, we are using now the channel 2. That is why this oscilloscope test probe. No? We have here an oscilloscope test probe. The BNC connector is actually connected to the input of the channel 2. Whereas the other 2 terminals at the end of this terminal here, we have here the alligator clip, which is connected to the ground, no, to the ground or to the negative side of the circuit. And this one, the hook tip, no, as you press downward, it comes out the hook tip. So right now we will be, yes, right now the oscilloscope test probe is now connected to the 2 terminals of the outlet, which is the source of the 220 volts, no? There is 220 volts right now, no? At the outlet. Okay. If you try to measure the voltage, it comes out the peak-to-peak value, no? Peak-to-peak value. So, you have to set here. This is a variable or a range selector switch. When you rotate this, it varies the amplitude. You have to select the voltage ranges here. So, the voltage range should be at 5, because we have 5 volts, we have 3 volts, we have 2 volts, we have 1 volt, we have 0.5, 0.3, 0.2. Those are the voltage ranges to be selected. However, the peak-to-peak voltage of this electric company that distributes 622 volts is beyond the capacity of this oscilloscope. This oscilloscope can only measure up to 500 volts as a maximum voltage to be measured, or that can be measured by this oscilloscope, no? Okay, let us try na lang to analyze. So, the number of divisions that we have here is around 12.2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It reaches actually to 12.2 centimeters because every division, the value is 1 centimeter. Okay? We have here 1 centimeter. Where is the... So there are 12.2 centimeters if we count the number of divisions on its vertical axis. No? There are 12.2 centimeters because every division is 1 centimeter times the range of the voltage that we are using now is 5 volts times there is a magnifier here. We are selecting times 10 because if we set it to times 1, the amplitude is very high, cannot be seen anymore. So we will divide it by 10. That's why it goes like that. No? It divides the amplitude of the sinusoidal waveform 10 times. So we have to write here times 10. So 12.2 centimeters times 5 is 0, 11, and this is 610. 61.0 times 10, the result is 610 volts. So the peak to peak voltage is around 610 volts. No, actually distributed by Severco company. No? Okay. Then what is the peak value? The peak value is equal to peak value divided by 2. The result is 610 divided by 2 is 300. Is when we divide 610 by 2, the result is 305 volts. That is actually the value of the peak value of one alternation, no? Which is 305. Then to get the RMS, which is now at the AC voltmeter. So to get the RMS is equal to peak value times 70.7% because the RMS value, which is the 220 volts at the outlet, is only 70.7%. So the result, peak value now is 305 times 70.7% is around 220 volts. That is how we get the RMS value, no? By multiplying peak value, which is 305, by 70.7%. And the result now is 220 volts. Okay. And to get the frequency, we need to count the divisions on its horizontal axis. So, let us move. We have here a control that position the image vertically. So, we have here, because these controls now are common to both channel 1 and channel 2. We have here the control for moving the, okay, we have to move the image sidewise. Set it to the center here. We have here. Okay. Set it. We should hold it, no? We should hold. Very hard to count. Okay, guys. Okay. The waveform now is held constant, just like this when we set to level hold control. So we can now count the number of divisions on its horizontal axis. So starting from this line, we have 1, 2, 3, 3.2. There is a 3.2, no? B, setting it to maximum level. If we count the divisions in horizontal axis, 1, 2, 3, 3.2. That is 3.2, no? The one with form. So, 3.2 centimeters times the range we are using now is 5 milliseconds. 5 milliseconds. So, 3.2 times 5 milliseconds is 16. So, we have 16 milliseconds. That is now the time varying frequency. So, to get the frequency, because the formula is frequency is equal to 1 over t or time, 1 by substitution over 16 milliseconds. 1 divided by 16 milliseconds, the result is 60 hertz. It is 60 hertz. So, we can actually measure the frequency of that outlet using also this tester, because this digital multimeter has also a meter which is frequency meter. Just set it to hertz. Try to measure. It reads here 59.8 hertz, which is almost 60 hertz. But since this is analog oscilloscope, no, it doesn't display the number. Instead, we can only measure it in analog way. No, that's why we are using the meter scale, which is not so accurate. We are only estimating. And the result now is 60 hertz. Measures only the one cycle. No, that is the way how we measure the frequency using this oscilloscope. Okay? And now let us come to the voltage measurement. No, voltage measurement at the circuit of this TV receiver. So, the voltage now is around, set it to AC, set it to 220 volts. The voltage now, which is at the TV receiver, because we are going to connect now the male plug of this TV receiver to the outlet of this variac transformer that distributes 220 volts. So, what will be the voltage across the this digital meter actually is set to AC voltmeter. Now registers the 220 volts that measures the voltage at the outlet, which is the actual voltage distributed to the TV receiver. This second voltmeter is set again to voltmeter, which is set to DC, which is at the output of the rectifier diodes or across the supply filter capacitor. No? This voltage actually 303 volts is at the output of the rectifier diodes or across this capacitor, which is also at the input of this regulator. Okay, it reached there 303 volts. How come it reached to 303 volts when the voltage being inputted by the Sulico is only 220? Meaning this capacitor now stores the voltage up to the peak value of the amplitude. Remember that what is measured by the voltmeter here from the outlet is only 220. But these capacitors, after rectification by these diodes, this capacitor stores voltage up to the maximum level, which is 303. Meaning to say that this capacitor is capable of storing the voltage up to the maximum level. And it is DC, huh? It is DC because it is first rectified by the diodes before it is stored by this capacitor. Okay? And the other tester or the third voltmeter will measure, this third voltmeter will measure the voltages that are distributed to the circuits. Okay, we have here By the way, how do we measure the voltages of the circuit? We will connect the negative side of your DC voltmeter. We will set it to DC voltmeter. The negative side should be connected to the negative side of the circuit. Where is the negative side of the circuit? It could be this bare harness wire that hugs the outer conductive coating, which is the negative side of the picture tube. The negative side of the picture tube is actually connected here to the negative side of the CRT drive, and finally connected to the main board, which is negative. You can also connect this negative of the DC voltmeter to the metals of this. The metals, no? Okay. How can we prove that the bare harness wire is connected to these three metals? By means of continuity tester. Using this analog, set it to times 1 for measuring the continuity. Okay, we have here. Okay, diba it deflects? We have here. So it goes like that. But if it is here, walang deflection. Do not connect your negative side to this metal because it is connected to the power line. They are not connected to these metals here, which is at the cold circuit. Remember that there is hot circuit and the cold circuit. Okay, you may connect it here, or you can connect this one here, or here, or here. But it is appropriate here because it is away from the circuit, but it is still negative side. No, connect this negative of the DC voltmeter to the negative side of the circuit, whereas the positive side will be injected to the electrodes of the transistors or terminals of the IC. Okay, like for example this one, no, we will permanently connect. The positive side of the voltmeter is actually connected to the output of the regulator, because this horizontal output transistor, the collector, is actually supplied with DC voltage from the low voltage power supply. And actually this voltage 120 volts is supplied by the switch mode power supply. Remember that this switch mode transformer, the switching transistor, together with the optocoupler here, there is optocoupler, or all of these components under the switch mode switching transistors are performing the regulation of the voltage. Meaning to say that whatever the input voltage, which is actually across this capacitor, which is 301 volts, is fed to the regulator, no? And the output is 119.9 volts or 120 volts, which is the regulated voltage. It is the regulated voltage. Remember that this circuit here is a DC to DC converter, because what is being regulated is actually the DC voltage across this capacitor, and which is the input voltage of this switch mode power supply here, the regulator. No, it is lowered down to 119 volts or 120 volts. No. So 119.9 volts or 120 volts. No, that is actually the voltage at the output of the low voltage power supply, which is a regulated one. Meaning, so let us try to vary the voltage. Okay, we have here. Okay, where is the connection here? Okay, let us try to connect this one again here. $303. Okay, remember that this is now the input voltage of the Solico. We will set it lower, 222, no? Then we will lower down the voltage to We will lower down it to 197 volts. Now the AC voltage which is supplied to the TV receiver from the outlet is 197. Then the voltage across capacitor after rectification is 268. It goes down. A while ago, it was 305 volts, but now the voltage output across the capacitor is only 268. It goes down because the input voltage AC from the outlet is lowered down to 197. But look at the voltage at the output of the regulator. Retains the same. It retains the same. Even you increase it to higher. Now we are increasing the voltage AC of the TV receiver to 230. Now the voltage across capacitor is also varied to 313 volts. A while ago, that was 303 volts. When the voltage at the outlet is 220. But when it goes down to somewhere at 180, the voltage there goes down also to 290 plus. But the voltage across at the output of the regulator retains the same. It's still 120, oh. Diba? Remember, oh? When you set it to lower, 204, the voltage retains the same. 119 or 120. When you set it to higher, the voltage at the output retains the same. Meaning, the low voltage power supply, which is equipped with regulator comprising of switch mode transformer, switching transistor, together with the optocoupler, will provide a relatively constant output voltage despite of the variations at the input. No? Nanatili pa rin permanente ang voltahe sa labas ng regulator kahit pa man sa pabago-bagong voltahe sa input. Okay. Actually, the voltage at the outlet is prone to variation. It bumps up and down every now and then. That is the essence or the importance of the regulator under this low voltage power supply. So, the low voltage power supply is distributing 120 volts now towards the horizontal output transistor. So, it is not only 120 being provided to the circuits, but also there is voltage supplied to the vertical output IC. Look at this one. It is 26 volts provided by the low voltage power supply. Before, last time class, my discussion about the voltages distributed to the circuit was general because the voltage that is supplied to the vertical, to the sound section, to the tuner sections will not be only originated from the low voltage power supply. There are sometimes originated from the high voltage section. Like for example, the Sony, the Panasonic, the Toshiba. But this one is a China board. Different brand, different models, different distributions of the voltage. For these TV receivers, the voltage for the collector, for the vertical out, for the sound section, are distributed by the low voltage power supply. We can also measure actually the voltage supplied to the digital circuit because remember, this is not purely analog because there is an embedment of digital ICs also. Like for example, this EEPROM is a digital IC. This UOC or Unified One Chip is a combination of Jungle and MPU. MPU, by the way, is microprocessor unit or micro computer unit that uses digital components or digital circuits. It is combined with analog because Jungle circuit comprising of color killer, chrome amplifier, sound IPM amplifier, luminance amplifier, the components being used are analog. So, combination of analog and digital. So, in this MPU, the voltage being supplied is 5 volts. Try to be sure if it is 5 volts. We have here. Is it 5 volts? here. Okay. The voltage is lower, somewhere at 5 volts to 6 volts. Also, at this keyboard, it is digital because every time that you press the touch switch, it distributes binary information, actually the binary code. So the voltage being supplied here is 5.2 volts. No? It should be 5.2 volts. Then the infrared, this infrared receiver, because it receives or it senses signal being distributed by the remote control. So the voltage supplied here is 5.2 volts, also 5 volts. Also with this, it is 5.2 also, no? Or 6 volts for the EEPROM, MPU, the keyboard, the infrared sensors receive 5 volts from the low voltage power supply. Okay, those are the ways how we measure the voltages at the terminals of the components inside the circuit, no? DC voltages. Now, going back again to the infrared sensor. What is this infrared sensor? And what is this remote control? We have here a remote control. There are keys or keyboards, no? When you press one of these keyboards, the infrared LED emits light and transmits the pulses. The pulses corresponds to the binary code or the binary informations. No? Binary informations to the TV receivers, specifically the infrared sensor. Infrared transmitter or remote control. Then we have here an infrared detector, infrared receiver that detects or receives the pulses being transmitted. The pulses actually are the binary informations, no? Being carried by 38 kHz. So this 38 kHz, by the way, class, 38 kHz is a carrier. A carrier. We have here pulses, series of pulses. Okay, when you press one of the keyboards here, this infrared LED emits light at invisible range. It is called infra. Infra means below. Red is visible. Meaning to say, it emits light at invisible range. Cannot be seen. Below the visible range. Kaya, the meaning of infrared is below the visible range. Cannot be seen by human eyes, actually. But when you press this, the infrared LED emits light and submits pulses. We have here the pulses. 5, 0, 5, 0 or 1, 0, 1, 0, 0, 0. These are the binary informations being transmitted by the remote control, being carried by there is a so-called radio frequency, higher frequency, which is 38 kHz, being carried because it is transmitted. So the pulses, actually, the binary informations are being carried by the 38 kHz. But as it receives by the infrared sensor and submit it to the MPU circuit, this 38 kHz is actually demodulated and filtered out. What comes out and fed to the microprocessor unit are the pulses only, containing the binary information. For example, volume up, volume down, channel up, channel down, different pulses. For example, for the volume up, you have here the pulses 1, 0, 1, 0, 1, 0, 1, 0. For example, those are the binary information being submitted by the remote control to the TV receiver as it passes the infrared sensor. Okay. The same is true with this Remember, the 30 kHz is being omitted or filtered out as it passes the demodulator circuit. Because what is needed by the TV receiver as it is detected by the infrared sensor is only the pulses. The 30 kHz will be used only to transmit, to carry the pulses to the TV receiver. But, this one, keyboard, every time that you press, it sends binary information also. Because when you press this, it turns on. The result is 5 volts. Because 5 volts is at the input. But every time that you press, it shorts the terminals. That's why the other circuit now